Okay, so today we're going to be doing inequalities with absolute values. Okay, now the bad news is this is probably the most confusing thing that you're going to do while I'm gone. But that's only because it kind of combines all the other things together, plus all the stuff of solving absolute value equations. The good news is most of these problems look very similar. So once you get used to them, then they're going to be very repetitive. You're going to be doing the same thing over and over again. The answers are going to look similar most of the time. So it kind of becomes repetitive. Alright, so let's start by a quick review of absolute value equations. So here I have the absolute value of 2x plus 2 equals 4. Okay, we should remember how we solve this. Remember, an absolute value actually has two values that could equal 4. So we set this up as two separate equations, because what's on the inside of the absolute value could be positive 4, because the absolute value of positive 4 is 4. So this could be 2x plus 2 equals 4, because that would be a solution for this equation. But also, what's inside the absolute value could be negative 4, because the absolute value of negative 4 is also 4. So I could also have the 2x plus 2 could really be a negative 4. So this one equation really breaks down into two equations. And then I solve each equation individually. So I subtract 2 from both sides, I get 2x equals 2. Divide by 2, and I get x equals 1. On the other side, I subtract 2, I get 2x equals negative 6. Divide by 2, and I get 2x equals negative 3. Okay, now, the only difference in an absolute value equation and an absolute value inequality is the equal sign. Now, we don't have an equal sign. Instead of an equal sign, we'll have something else. Okay, but since there's no equal sign here, well, that also means there's no equal sign here, or here, or here, or anywhere else in this problem. Okay, instead what we have is an inequality. So now, instead of absolute value of 2x plus 2 equals 4, I have the absolute value of 2x plus 2 is greater than 4. So you can think of it the same way, though. If the absolute value of 4 would equal 4, then the absolute value of something greater than 4 would be greater than 4. So instead of using the equal sign, I just use the same sign. And then we know from the last couple days that that also means I'm just going to bring down the sign. There's nothing I did to flip it. So instead of x equals 1, I end up with x is greater than 1. Okay, now let's also think about the other side. Because if the absolute value of 4 is 4, and the absolute value of negative 4 is 4, okay, well, something greater than 4 would give me a number greater than 4. Would a number greater than negative 4 give me greater than 4? Well, 0 is greater than negative 4. If I took the absolute value of 0, that would not be greater than 4. Okay, so you actually need a larger number, but larger negative. So you need this number to be something like negative 10. Because then when you took the absolute value, you would get something greater than 4. So on the negative side, you need the opposite sign. So instead of greater than, I have less than. And then I follow my inequality rules, and that sign would never flip because I didn't multiply or divide by a negative number. And my solution here, instead of x equals negative 3, is x is less than negative 3. Notice, my solution is very similar. The only difference is the signs. Okay, I have x is greater than 1, x is less than negative 3. So, one of the first things you really have to understand is that an absolute value inequality gives you a compound inequality. Which should make sense because when we solved absolute value equations, we got two solutions. So it should make sense that an absolute value inequality would give you a compound inequality. Alright, so let's talk about our steps. Step number 1. The same step number 1 as when we were solving absolute equations, absolute value equations. Get the absolute value by itself. Because you cannot, the reason that's the first thing you have to do is you cannot split this into two different inequalities until all you have is an absolute value. Okay, so that's got to be the first step. Get the absolute value by itself. Okay, then step 2. Write two inequalities instead of the one. Okay, and don't forget to flip the inequality on the negative side. And then step 3, solve each inequality. Now, there's actually one more step. I'm hoping a lot of you have kind of been wondering, because we can't have a compound inequality if all you have is two inequalities, because we have to have a statement. This has to be an and or an or. You can't just say two inequalities. Well, I don't know if it has to be both of them or if it can just be one of them. Okay, I don't know if it's this or that or this and that. Okay, so step 4. Okay, this sign tells you step 4. Okay, it's a very simple process, and I'm going to explain why it works on the next page. But it's very easy to remember. Less than. So in other words, if that's a less than symbol, you use an and. Or great or. If it's a greater than symbol, you use an or. So since this one is greater, I use an or, and that's my compound inequality. X is greater than 1 or x is less than negative 3. So that's the compound inequality. That's the solution for this absolute value inequality. Alright, so let me explain why this less than and great or works. Okay, let's get a very simple example. Alright, so we've got the absolute value of x is less than 2. Okay? Well, think about what that means for our solutions. Okay, x has to be less than 2 so that the absolute value of x can be less than 2. But if x is less than negative 2, then that wouldn't be less than 2 because the absolute value of negative 3 would be greater than 2. So my two endpoints are 2 and negative 2. My solutions are numbers like 1, 0, negative 1, 1/2, negative 1.5. Okay, they're all these numbers between 2 and negative 2. Because if an absolute value has to be smaller than a number, then that means it has to be closer to the 0 than that number. So it has to be from the 2 to the 0 or the negative 2 to the 0. So this is what this absolute value would look like. This is why a less than symbol with an absolute value causes you to have an and statement. Because these are the numbers that have an absolute value of less than 2. Are the inside numbers, or the middle numbers, if you want to think of the number line as being, the 0 being the middle. Okay, the numbers in the middle have less value because they're closer to 0. So less than would have to be a piece of the middle. All right, and the counter example of that is for greater. We have the absolute value of x is greater than or equal to 2. Now, the or equal to doesn't really do anything. I just wanted to kind of remind us what it looked like on the graph. Okay, but I've got my graph again. All right, so again, I have endpoints of 2 because I need the absolute value of x to be 2 or greater than 2. Okay, so that means my two endpoints are negative 2 and 2. Except this time I need the absolute value to be bigger than 2. Or it can be equal. So the only thing the or equal to changes is I make those 2 points closed this time. Alright? And this time, since I need a greater value, well, the greater values are on the outside of the number line. Because the further left I go, the bigger the numbers get. The further right I go, the bigger the numbers get. So if I want something greater than 2, I have to go away from 0. Like negative 3 and positive 3 and 10 and negative 10 and all those. So that gives me an or statement. Okay, so anytime the symbol is less than, you get an and. Anytime the symbol is greater than, you get an or. Okay, that's what I meant about repetitive, because it's very simple to see what your graph is going to look like just by looking at the symbol before you even start the problem. Now you have to solve it to see where the endpoints are, okay, but you already know what kind of graph you're going to get before you even start. Now, there are a couple of tricky ones, so I want to look at those, and then we'll do some practice problems. Okay, what about something like this? This looks pretty simple. This time I just have the absolute value of x is greater than negative 2. Well, I could solve this and do it the same way, except for what do we know about absolute values? If I take the absolute value of any number, what am I going to get? I'm going to get a positive number. Well, so is there any positive number in here that would not be greater than negative 2? No, because a positive number is greater than a negative number, no matter what positive number it is. So literally, anything would work for x, no matter what you put in there, because it said the absolute value is greater than a negative number. Well, the absolute value is always greater than a negative number. The smallest an absolute value can be is 0. So it's always greater than any negative number. So this solution would be x is all real numbers. Okay, if I was to graph this, you can see it would be an or statement. So I would actually look kind of like this one, except for the arrows would be pointing away from each other, and it would be an or statement, so I would keep the entire line. So the entire number line is a solution. Okay, but you should be able to recognize something like this before you even waste your time doing the work. All absolute values are greater than -2. All right, the other side of that coin is when you have something like this. Okay, the absolute value of x is less than 0. Well, you could try to solve that, and you could do it the same way too, except for you'd get a graph that looked kind of like this maybe, except for it would be an and statement, because this is less than, so you would only keep where they overlap, so they wouldn't overlap anywhere. Well, why wouldn't they overlap anywhere? Because there is no value for x that would make this true. No absolute value is going to be less than 0. Okay, so I have no solution. Okay, so here's the two types of problems where you wouldn't get a normal answer. Okay, is when you have something that's going to be all real numbers, like an absolute value is greater than a negative number. Okay, or an absolute value is less than a 0 or less than a negative number, would be no solution. Okay, so watch out for those. But other than that, most of the normal problems, the less thans are going to be ands. They're going to look like this. The greater thans are going to be ors. They're going to look like this. You're just solving them to find the endpoints. All right, so let's try some. So you're going to solve and graph these absolute value inequalities. Alright, so we've got the absolute value of 4p plus 2 is greater than or equal to 10. And we've got the absolute value of m plus 2 over 3 is less than 4. Alright, so go ahead and try to solve and graph those, and then we'll look at them together. Alright, so first I see that number 1 isn't one of my trick ones, because there are absolute values that could be greater than or equal to 10, but there are also some that aren't. Okay, so I know I need to solve this. I have the absolute value by itself, so I need to split it into two inequalities. So I have 4p plus 2 is greater than or equal to 10, and I have 4p plus 2 is less than or equal to -10. Okay, see, I kept the signs the same over here, and I switched both signs over here, the inequality and the negative. Alright, so now I can solve them. Subtract 2 from both sides, I get 4p is less than or equal to, greater than or equal to 8. I don't flip the sign because I didn't multiply or divide by a negative. And then I divide by 4, and I get p on the left and 2 on the right. I didn't flip the sign because I didn't multiply or divide by a negative. Okay, on to the second inequality, subtracting 2 from both sides. This time I get 4p is less than or equal to -12. Divide by 4, and I get p is less than or equal to -3. Again, I did not switch the inequality because I didn't divide by a negative. The negative was already there. Okay, then I'm looking at the sign. Since it's a greater than, it's an or statement. So my solution is p is greater than or equal to 2, or p is less than or equal to -3. So now I can graph that. Okay, I'm going to start with this one. P is greater than or equal to 2, so I circle my 2. Since it can be equal to, I close it. And greater than 2 is to the right. Then I plot the second point, or the second inequality. P is less than or equal to -3, so I find my -3. Since it can be equal to, I close it. And since P is less than -3, I'm going to the left. Now, since this is an OR statement, I keep both lines and I'm done. So that's the solution and the graph for that absolute value inequality. Alright, and the next one. Same thing. I can see that absolute values could be less than 4, but they could be greater than 4 too, so there's no trick here. I need to go ahead and solve it. Alright, so the absolute value is isolated, so now I can write my two inequalities. So I have m plus 2 over 3 is less than 4, and I have m plus 2 over 3 is greater than negative 4. So I solve each one, multiply by 3 on both sides. M plus 2 is less than 12. Subtract the 2, and I get m is less than 10. On the right inequality, again, I'd multiply by 3. This time I get m plus 2 and negative 12, but I still didn't flip the inequality because I didn't multiply by negative. I multiplied by positive 3. Alright, and then I subtract 2, so I get m is greater than negative 14. Again, I didn't flip the sign because I didn't multiply or divide by a negative number. Okay, this time I look at the original inequality and I see it's less than, so that lets me know that this is an AND statement. So my solution is m is less than 10 and m is greater than negative 14. Alright, now the first thing I notice is those numbers aren't going to fit on a scale if I'm counting by ones, so I'm going to count by fives. Alright, so I've got negative 15, negative 10, negative 5, 0, 5, 10, 15. Alright, I'm going to plot this first inequality. M is less than 10. So I find my 10. I leave it open since it can't be equal to 10. And m is less than 10. So my arrow goes to the left. Then the second inequality. M is greater than negative 14. So I find my negative 14. I leave it open since it can't be equal to. And since m is greater than negative 14, I'm pointing to the right. This is an AND statement, so I only keep where these two lines overlap. Well, this arrow keeps going forever to the right, but over here, they're not overlapping. This arrow keeps going to the left, but over here, they're not overlapping. So I only keep what's in between those 2 points. So this is the solution and the graph for that absolute value inequality.